Mm-hmm. Right. And yep, I'm live and the sound is too high. And it's fine. And with a better camera today. Let's just begin. And yesterday, yes, I was unable to get the thing that I was trying to do working. So we are going to skip it and move on to the next one. And maybe I will do this in the future at some point. And probably I won't. But yeah, that is it. Functional programming. Start the course. Shit. What is functional programming? Functional programming is a style or paradigm. If you are pretentious, pretentious, okay, of programming where we compose functions instead of mutating a state, updating the value of variables, where we compose functions, okay. Functional programming is more about declaring what you want to happen rather than how you want it to happen. And imperative or procedural programming declares both what you want and how you want. Okay. Imperative code is car equals create car, then car dot get gas this and clean windows. Example of functional programming. Create car, add gas, and clean windows. Okay, so in this we have a thing called car, which is returned by create car function, and then we are updating its space, its value one by one, step by step. But in functional programming, we have a value which is returned by this function. We are giving that as an input to another function and that as an input to another, like pipelining. The important distinction is that the functional example, in the functional example, we never change the value of the car variable. We just compose. Yes, we are not changing the value of the car variable here. We are just giving it in as a value and getting some other value. We just compose functions that return new values with the outermost function clean windows, in this case returning the final result, doc to doc. In this course, we are working on doc to doc command line tool for converting documents from one format to another. If you are familiar with pendoc, the idea is similar. What is pendoc? Pendoc.org. Shit. Shit, this image is looks shit. I can convert all these formats into all those other formats. It seems like from Markdown to JSON. That is cool. Okay, and RST to PDF and stuff. That is cool. That is cool. How does that work? Unlike the internals, but what is this? Lightweight markdown formats. If you needed to convert files from one markdown for only about markdown, okay, from one markdown format into another, Pandoc is your Swiss Army knife. Pandoc can convert between the following formats: conversion form to conversion to and conversion from to. Okay. Then assignment: complete the stylized test. This thing function, it should take a single string as input and return a single string as output. The returned string should have both the title centered and a border added. Okay, okay. Title centered and border added. Return add border for center title on document. That should work, I guess. Yep, that does work. And yep, that is correct. Now moving on. Why Python? Frankly, Python is not the best language for functional programming. Reasons include not a static type. Yep, types change. I do not know what a function is going to return. Almost everything is mutable. Yep. No tail call optimization that I do not know. Side effects are common. Yep. Side effects that means your function has changes some values which weren't even passed into it, like some global variable or something. Imperative and OOP, object-oriented programming styles, abound in popular libraries. Purity is not enforced. A pure function is something that always functions the same way. For given input, it always outputs the given same output, and sometimes not even encouraged. Sometimes are hard to define, and pattern matching is weak at best. So seriously, why are we using Python? One reason trumps all. You already know Python. Python is a great choice for learning coding basics, OOP, algorithms, and data structures. And the trade-off of learning a new language at this point in the curriculum isn't worth it. We can still cover more important concepts of functional programming in Python, even if we have to jump through a hoop or two to do it. Functional programming is a paradigm of useful techniques for writing better code, and they apply to all languages, not just purely functional ones. Note, we also plan to release a functional programming 2 course in a more functional programming language, like one of these, Haskell, OCaml, Elixir. That would be amazing. They are planning to release a functional programming 2 course. I will read about OCaml. OCaml is a systems language, I suppose, and Haskell, I have no fucking idea. Haskell programming first principles. Shit. What is it? A purely functional, statically typed programming language known for its strong type system, lazy evaluation, and mathematical foundations. What does it look like? Like this. Funk. Uh-huh. Okay. That looks. Okay, this notation where we use semicolon to represent something, I do not know what, is taken from C++, and it is also in Rust, and I have no idea what the fuck it means. It will be fun to read about Rust and C++. Why learn functional programming in Python? Because we already know Python. Yo. And immutability in FP, functional programming. Okay, we strive to make a data immutable. Once a variable is created, it cannot be created. Once a variable is created, it cannot be changed. Mutable data types, data on the other hand, can be changed after it is created. Who cares? Immutable data is easier. Immutable data is easier to think about and work with. When 10 different functions have access to the same variable and you are debugging a problem with that variable, you have to consider the possibility that any of these functions could have changed the value. When a variable is immutable, you can be sure that it hasn't changed since it was created. It is a hell of a lot easier to work with. Generally speaking, immutability means fewer bugs and more maintainable code. Okay, the screen is fine and everything is fine. Maybe I can reduce the volume a bit. Well, I do not know how much of the volume you guys can hear, but I can hear a loud music at times. And I have also planned what I will do for my 100th stream. It's going to be amazing. It will be fun, actually, for me at least. Tuples versus lists. Tuples are lists. Tuples and lists are both ordered collections of values, but tuples are immutable and lists are mutable. You can append to a list, but you cannot append to a tuple. You can create a new copy of a tuple using values from an existing tuple, but you cannot change the existing tuple. Lists are mutable. I can do append and in tuple, note the comma. This, yes, it is required because if it is not given, then this will be just taken as an expression as two brackets that hold 80. So it will more edges will get the integer 80. Now this we get a brand new tuple assignment. Add prefix function accepts two arguments. This document a string and document the current tuple of a string. Okay, it should do two things. Add a prefix of x dot to the beginning of the new document where x is the next document in the tuple. Wait, document is a string, so prefix. That makes sense. Okay, it is already doing what it is supposed to do, I suppose. And document and should be this. Documents length. Okay, okay. Current document length or this. New document is prefix plus document, right? And documents dot append new document. Okay, since when I go to see the error, yep, it is error. What I actually have to return is documents plus new doc, comma. That should work, I guess. Yep, that does work. I created a tuple and added the two together. Yo, open chest. Yo, I'm rich now. Now, stop the music.
There are many parts of functional programming. Recursion, pure functions, immutability, higher order functions, and these are just a few of the concepts. But I'd argue that the main purpose of functional programming is to make our code more declarative. CSS, I know, disgusting, is actually a great example.
Declarative. That is, you just tell what you want and you do not have to worry about how. That is declarative.
Example of declarative language. Take a look at this simple snippet of CSS that turns the color of a button red. There are no step-by-step procedures. We simply declare, I want buttons to be red. The browser then takes that declaration and implements it. It applies it so that all the buttons on the website are actually rendered as red on the screen. Now let's take a look at a similar example that's implemented
Peeking
in
time.
procedural, non-declarative Python. First, we get right into the nitty-gritty of the implementation details by importing the tkinter library. Next, we'll create a new GUI window. We'll set the size of the window. We draw a red button on the screen. And finally, we call the main loop that keeps the window open and listens for any incoming events. The key difference here is that in the procedural Python example, we're very concerned about the how in addition to the what. When we're writing declarative code, we really just want to worry about the what, right? The fact that we want red buttons. Good old mathematics is another great example of a declarative language. And that's why functional programming is often more popular with mathematicians. Take a look at this equation. X equals 5 times 10 plus 6 times 11. The equation doesn't tell us in which order we need to carry out each computation on our hardware. And it also doesn't tell us exactly where we should store each value in the memory on our computer.
Just do this.
We could write the code this way, or we could swap the ordering around like this, and we'd get the same result either way. Purely functional code is mostly a pipe dream because at the end of the day, somewhere we need to specify how to get stuff done. But we can continuously try to make our code more and more declarative, which means more and more functional, by hiding the implementation details at a lower level. So the goal of the functional programming style is just to bring us closer and closer to this declarative ideal.
Declarative. That makes sense. Declarative, like it is like a React. Functional programming aims to be declarative. We prefer to declare what we want the computer to do rather than muck around with the details of how to do it. Let's take an extreme example and pretend we want to style a web page with CSS. Obviously, hypothetical, because why would you want to work on the front end? Oh, that is the reason that they were looking down on CSS because it is front end. Declarative style. The following CSS changes all buttons to red, and yep, I have seen it before, and yep. This is to create something on the screen using the tkinter library. Let's see, and tkinter.py and paste all of this. Wildcard import from a library not allowed. Import tk, right, and tk and comma button. Can I do that? Yes, I can. And this should work. Python 3 like tkinter.py import cannot import name tk from tkinter. Why? Tkinter has nothing like that. Python tkinter.py Python 3 tkinter.py. Okay, every time I try to do something new, tkinter.py, and I do not see any error here. Hmm. 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 I don't see any errors here. Ah, fuck. Okay, this was not the thing. CSS is typically declarative. It just tells what it wants, not how it wants it to be done. This is the same. A script that does one thing after another is a script that does one thing after another is that does one thing after imperative, I guess. Yeah, because it is actually doing stuff, not declaring what it just wants to happen. It's math. Functional programming tends to be popular among developers with a strong mathematical background. After all, mathematical equation isn't procedural, it is declarative. Take the following equation. This averages summation of x divided by n. To put this calculation in plain English, sigma, the sum of the collection, adds up all x divided by n, and average is equal to that value. So the equation really just says that average is the average of all the numbers in collection x. Wait, I want to test average dot py. I want to test something. Let's say I have an array which has a bunch of numbers. Okay, right, and equals and this, right. Now I can calculate the array in two ways. Left loop average by 2. This will take in the array, and okay, and this will do average equals 0, and for I in air g average equals avg average plus I divided by 2, and at the end return average. I think this should work, and average by default method, whatever is the default method, which is first sum everything for I in air average plus equals I, and then return avg divided by length of r. Now let's see if both of them return the same answer. print avg by 2 for r and print avg by default for r. Python uh, Python 3 avg average.py, and they return totally different things. Yes, they return different things. First one, yeah, average by 2 I guess is wrong, and average by default is correct. If I'm averaging two numbers, I'll find their average, alright. And if I bring in a third number and find its average with the average of these two, with the average of this new average, then I should get a correct number. So let's make this. This is like I'm going off the path here. This is not the stream is about. 1, 2, 3. Let's just take three numbers. Python average.py. Okay. And what do I know? The average in this case is 2. Therefore, the average by 2 is wrong, and average by default is correct here. Average by 2, why is it wrong? First, I will go and take the average of 1 and 2, which turns out to be 1.5. Yes, which is 1.5, and then I take 1.5's average with 3, and it is not 2. Why? Delete raw. Shit. Why does it feel like it should be 2? Okay, I have numbers and I will represent them by bars. Okay, this is 1, this is 2, this is 3. And when I'm trying to average them, I'm trying to figure out a way in which, let's say, I cut all these bars from the length that is the shortest. So I have this remaining and this much remaining, and I need to put take add both of these, right? So I would have a bar, this bar here, and this bar starting from here, and I need to add and then distribute all this remainder into three parts, these three, and put them above here like that. 1, 2, and 3. And then the height that I get is the average. Right, that seems correct. Mhm. Then the height that I get is average. Right, so in the normal method, in by default function, this is what I'm doing. And in the other method, divided by 2, what I'm doing is among these bars, first I am taking the average of these two, and in that I take let's say I take this and this one, and this color is horrible, absolutely horrible color. In this I take these two bars, and then I cut this one from here. We'll use another color. Then I cut this one from here, and this is what I get, and I divide this into two parts, and I put half of it here and half of it is here. As 1.5 is the average. This was 1 and this whole was 2. So now I get 1.5 as the average. So now I have a bar. What do I have now? I have 1.5 and 3. Okay, and at the end, in this, I am losing some bar. Hmm. What should I take three's average with to get 2? I should take it with 1. If I were to cut this from here, I will have 1.5 length remaining. And if I were to divide that 0.75, and I would add 0.75 to this, and I would get 2.5 as which is wrong. Why? Well, I am losing length at some point. I am certainly losing here. In total, I went in with 1 plus 2, 3, and at the end, I got 1.5, half of it. Okay, which is wrong. Which is wrong. No, 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 no. Um, mm, mm, uh, Here I have 1.5 remaining, but in shit, yes, fucking yes, yes, I get it. Instead of doing this, yes, yes, yes. Fuck yep. After this step, I'm getting a bar of 1.5 length. But the thing is that I'm getting 2 bars, right? Two, not a single one. I'm getting 2 bars. So at the end, when I take the average with 3, I have, of course, the bar which is 3 in height, and I have 2 bars, each of 1.5 height. Yep, I have 2 bars of 1.5 height. So when I take the average of these 3, therefore, this after cutting this, it will be divided in 3 parts, and these 3 parts will be equally given to each one. That is more than 3 parts, and this 3. Yep. So I know that these are in height 1.5, and after cutting from the lowest height, I get 1.5 in here, and if I do divide 1.5 into 3 parts, I get 0.5. And now, since these 3 are remaining after cutting this one, they are 1.5 each. Then, after giving zero point 0.5 height to each, I get 3 bars, which are 2 less in height, which is the correct answer. So, I can add it, but I will have to divide it with the now counter. Average by 2. No? I equals to 2. Not I, but like n equals 2 divided by n and 2n plus 1, 1. Right, and let's see. Wait, let me bring the first edit that was there, the big one. And this is, yes, of course, on the path. Like, this is not what I started the stream for. N starts at 2 and divide this by n and n plus equals proving mathematical stuff. Shit. And Python average. Okay, in the new app. Yes. No, 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 no. I can. Yes, I have to divide this thing that remains. Okay, not this, but the thing that remains. Okay. I minus AV divided by n. I minus AVG divided by n. If I is smaller than AVG, and if it is not, then I will have some problems. So I will be adding, and EVP has to be multiplied by n. In the starting it will be 0, but in the second part it will become 2. Oh, shit. So I have to multiply this by n minus 1, making it even more complicated. Yes. Now I support my work. Nope, not even close. Uh-huh. Uh, oh yes, of course. This here. Mm-hmm. Closer, 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 closer. So I am multiplying average by n, which means at this point I have average of I am multiplying average by n minus 2. Yep. And I give it adding 3. So I have, what do I have? I have the combined length of all of these things, and I am dividing that length into these among them. Okay. Okay. This starts with 2. This should not. This should. This starts with 2. Therefore, this should not start with 2. This should start with 1. Yes. That's okay. Now it works. And this looks kind of beautiful and clean due to some reason. Escalator. Yeah. Yep. It was this statement that triggered all of that. So the equation really just says average, find the average, like the default method. However, with function programming, we could write code that is a bit more declarative. Get average, what does get average does? Sum and divide by length. Here we are not keeping the track of the state. Total variable in the first example is stateful. Yep. This has a certain state to it, stores the state through loops, and this one does not. It just finds the sum and divides it by length and doesn't care about the sum later. It discards it immediately after using it. We are simply composing functions together to get the result we want. Assignment. In the world of document conversion, we sometimes need to handle the font and font size. Complete the getMedia font size function. Given a list of numbers representing font sizes, return the median of the list. For example, this. Okay, median is like half of the numbers are larger than this. Yep, half of the numbers are larger than this. Notice that the second list is out of order. Out of order. Complete the. What are they talking about? Order. Notice the second list is out of order. Order the list. Then find the middle index and return the middle number. That makes sense. Median is finding just that. If there is an even amount of numbers, return the smaller of the two number. I know this it's not a true median, but good for our purposes. If the list is empty, just return none. Here are some useful docs. Okay, font sizes dot sort it, and yep, and sorted list is this. Then okay, I want to do this in a single line, but before let me do this like this. I will do it in a single line. I want to take the sorted list, and what do I want from the sorted list? I want the middle element in the middle. And how do I get it? I do length of font sizes divided by 2. Floor divided by 2. Right, that is amazing. Return this if length of font sizes greater than 0, else return null. That should does not, else yep, not return, else null, run. And that is expected 3. What did it get? Trace back, call which part? This none type is not a subscribable object. Okay, so it's because I might be trying to sort empty array. So return null if this size equals 0. Otherwise, return this thing. Again, mm, sorted. Okay, so sorted. It takes an iterable and key. It says reverse or reverse false. Okay, I can just given the iterable to that function. Uh, and sorted. Let's see, and that works. One field. Okay, which field? This one field. Input was this. Expected this, but got this. Why? Why? 4 divided by 2 should return 4 divided by 2 should return 2. Okay. If it is odd, 3 will return 4. Okay, but if it is not odd, then I have to do something with it. Okay. This if len if len font sizes, it takes its remainder by 2 equals 1, else return length of font sizes divided by 2 minus 1. Okay, that is very horrible code, but that does work. Shit. When it is empty, null if length of this is 0. It was this and expected none. I got null. I should return none. Okay. Okay, and the distinction between the two, that does work. And now classes versus functions. Functions take in values and return new values. Classes have their own data, and we call methods on classes, and that changes that data inside the class, inside that specific implementation of that class. And new developers, once after learning classes, want to use them everywhere. They assume that because they learned about functions first, functions are somewhat inferior. No, they are just different. Functions or classes. Here is my rule of functions. I'm reaching for when I need something long-lived and stateful. That would be a more model if I could start if I could share behavior and data structure via inheritance. This is often the case for video game simulations GUIs. Okay, this man is into video games simulations and GUIs. The difference is classes encourage you to look at the world as a hierarchical collection of objects bundle behavior, data, and state together in a way that draws boundaries between instances of things, like chess pieces on a board. I don't get the second part. Objects bundle behavior, data, and state together. Objects bundle behavior, data, behavior, data, and states together in a way that draws boundaries between instances of things like chess pieces on a board. I haven't even finished one chapter. How long has it been? 41 minutes. Fucking hell. And I stopped the music earlier. It is not good. Now it's fine. Just fine, but better than fine. Interstellar. It is not a ghost. Mhm. So you guys cannot even hear it. I myself cannot hear it. That is fine. And yep. Functions encourage you to think about the world as a series of data transformations. Yes, functions take data as input and return a transformed output. For example, a function might take the entire state of a chessboard and move as input, entire state of a chessboard and move as an input and return the new state of the chessboard as output. Yep. Which is where they are good in their own special ways. Yeah. Which encourages you to break down problems into instances of stateful things, classes, and being functional, professionally impossible, even for tenured senior developers to write perfect code the first time. That is why debugging is such an important skill. The trouble is sometimes you have these elegant sarcasm intended one-liners that are tricky to debug. Mhm. Like get function position, it takes in position, velocity, friction, and gravity. Return calc gravity for okay. First, I will calculate the position given the position and velocity. Calculate the move given the position and velocity. Then I will, after getting the move, I will add in friction and calculate the friction for that move. And then I will add gravity and calculate gravity for it. If the output of the get position function is incorrect, it is hard to know what is going on inside that black box. Break it up, then you can inspect the moved, slowed, and final variables more easily. Up, moved, slowed, final. Okay. Once you have run it, found once you have run it, found the issue and solved it, you can remove the print statements. Fix the format line function. What does it do and what is it supposed to do? It should apply the following transformations in order. Strip white spaces from the beginning and end of the line. So R is strip that does it. I suppose capitalize each character in the line. That is what it does. And remove any periods from the line. No, periods are periods, not commas. And suffix the line with an ellipsis. Words go here. Uh-huh. Uh-huh. P. Shit. Words go here. 1, 2, 3. Right, and that should work. Run the code. You should see that some subtle bugs are present. All of them failed. Okay. Don't lie. Words go friends don't lie. WORDS words go here. 3. Yep. Mm, that should have worked. Suffix the line. Suffix after the line. Then oh, words go. Okay, words comes here and then 3 dots. Okay, my bad. My absolute bad. And the thing that remains is to make it capital. Why is it not capital? R strip was what is R strip? Let's just use strip and friends don't lie. Capitalize Python 3. Uh-huh. ABCD dot capitalize. Okay, it only capitalizes the first letter. I want to capitalize the whole thing. How to capitalize strings in Python. Capitalize method, it only capitalizes the first. Yeah, so capitalize, I guess, is not the correct thing. How to capitalize whole string in Python. Upper, dot upper. Okay, that makes sense. I'll use the dot upper instead of this. Vim dot upper, and that does work. Submit. Function versus object-oriented programming. Functional programming and object-oriented programming are styles for writing code. One isn't inherently superior to the other, but to be a well-rounded developer, you should understand both well and use ideas from each when appropriate. You will encounter developers who have functional programming and others who love functional programming and others who love object-oriented programming. However, contrary to popular opinion, P and OPP are not always at odds with one another. They are not opposites of the four pillars of OOP. Inheritance is the only one that doesn't fit with functional programming. And yes, functions also do encapsulate, they also abstract and polymorphism. A single function can be used for different purposes depending on the data type that is provided to that function. Okay, inheritance isn't seen in functional programming due to the mutable classes that come along with it. Encapsulation, polymorphism, and abstractions are still used all the time in functional programming. When working in a language that supports ideas from both functional programming and object-oriented programming like Python, JavaScript, and Go, the best developers are those who can use the best ideas from both paradigms effectively and appropriately. Functional and OOP are all about writing code that runs on any machine, writing cleaner code, yeah, writing cleaner code, and OOP's concept of dash conflicts with the functional programming. Inheritance. Yep, that does work. And now it is just three optional stuff, which I can just simply skip. Functions as values. Shit, my screen has been unseen. Now my camera is not working. Shit, I thought it would work. Fucking hell. I guess that is the end of the stream for today, and I can do the rest of this offline. Maybe today I will complete it on my own. Maybe not. Maybe more. Maybe not. And it is like since this is learning, uh, so